Hi and welcome to a new video regarding Unity and AR, and this time we're going to do something that was requested quite often. We're going to update the AR indoor navigation sample, but instead of just updating the old one, we're going to re-implement it in Unity 6 with new features, new technology, and we're going to simplify it to a level that you won't have to code that much as we did in the last tutorial, but it will still have quite the functionality. So first of all, I started here with Unity 6 with a blank project, and in case you want to do it too, I installed the version for 6.0.12 and make sure that the Android build support is installed too. I installed the Windows build support too here. That's not necessary, but you can do it as well. And just create a new project in the URP, in the Universal Render Pipeline, and you will end up with the start screen like this. So first of all, we're going to remove the README assets. And we're going to go to File, Build Profiles, and switch to Android. Switch platform. When this is finished, we're waiting for the compiling to finish. And open the player settings, either by clicking here or by going to Edit Project Settings. And in the player settings, we're just leaving most of the stuff like it is. We're going to remove Vulkan here and switching this one to a new description, like, indoor nav, leaving most of the stuff as it is, and we're going to switch the input handling to the new one. So after Unity has restarted, we're clicking on the graphics settings, and we see that the PC RP asset is chosen here. We're going to choose the mobile RP asset, clicking on OK. And on quality, we're going to switch to mobile. The next step is switching to our XR plugin management, install the XR plugin management. And on the Android side, we're going to install AR Core. And for testing, we're going to install the XR simulation here. Let's check the settings. AR Core that required is good. Project validation. There are no rules. Here we have the minimum Android version. We're going to fix this, and on XR simulation there's nothing to do. That's basically it for the settings side. We're closing this. We're closing the build profile. So now we're going to Window, Package Manager. And in the package manager, let's check if the AI navigation package is here and if we can update it. So we're updating it. It's not necessary, but you can do it. And the next step would be AR Foundation. AR Foundation is already installed because we chose the Android package, the AR Core package. And that's it. We can now basically start implementing, but before that, let's check what we're going to do. So we're going to implement AR Core in the navigation, and before doing that, we have to check if our device is supported. And in our special case, as we're using the depth estimation, we're going to look at every smartphone that supports the depth API. So this is a requirement here. If your smartphone does not support depth API, you cannot do it the way we are doing it here. So you should refer to the older tutorial, which is also on my channel. But mostly every new device, or even the older ones, support depth API. I have here a Google Pixel 8 Pro depth API, and as you can see, there are a lot of phones supporting the depth API. So it's basically possible for almost every phone to run this. Motorola, OnePlus, Oppo, Samsung, especially when we're starting here. Go over here. I think that's a very common phone by the way, and so on and so forth. There's a lot of depth API support here. And the feature that we're going to use because of this depth API is the occlusion feature. So when switching to the Unity documentation for AR Foundation, under features there is this occlusion feature. And the occlusion feature will help us to render our scene the way the background would occlude our digital objects with help of the AR Occlusion Manager component. I have a Google phone, so the human segmentation does not work on my side. It's only the environment occlusion, but we'll just take it like this and start implementing. And for the navigation part, we will use the AI navigation from Unity with the NavMesh. And that's all for the theoretical stuff. Let's get started. But before we can get started, there's one thing we have to do beforehand. We're going to the mobile renderer asset, which we've chosen here, and we have to add a renderer feature here, which is called AR background renderer feature. And this will take care of our augmented reality background, so the camera image is visible in our application. Deleting the main camera. We can also delete the global volume, we don't need it here. And right click in the hierarchy, XR origin mobile AR. Just leave it like this. And the tracking origin mode will be set to device. So the device will be our single point of truth here. And we don't need any camera offset. You can just set it to 0 here. And down here in the camera, main camera, there's everything already set up. We will add the AR Occlusion Manager here. Add component AR Occlusion Manager. And let's see depth mode. We can just go to best here. Temporal smoothing and everything else disabled, and prefer environment occlusion. Save it. And that's the setup for having our depth occlusion and the AR rendering. And we're going to have an image as our anchor point here. So we're going to add an AR session here. Right click XR AR session. And this AR session will take care of our session itself so that the image tracking will work too, but the image tracking will have to be moved here to the XR origin. So it's AR tracked image manager. This will take care of our image tracking. We don't need a prefab here, but we need a serialized library. So let's create a new folder in our assets folder, call it, I don't know, image tracking. Right click, create XR reference image library. Let's keep the name, add an image. We'll add that in a second. Click on XR origin and reference the library here so that our AR tracked image manager can check if our image is tracked. And I'll just copy my image in here. Give me a second. Here it is. It's the Unity logo I pulled from the samples, from the AR Foundation samples, and I'm checking that this is spread to the MUI, apply it, and add it here as a texture. You can also specify the size, and we will do the 2, specify size, and let it be 0.1, so it's 10 centimeters each side. That's it for the image tracking, and we're now going to create a new folder which is called scripts, as we need a few scripts, and creating another folder called materials. So what we're going to do is we're going to track the image, and then we're going to spawn our NavMesh and let the NavMesh do the navigation work as soon as we're having the image in our viewport. So we're going to need another folder called prefabs. Save the prefab there, respawn it manually. And let's create a new material here. Call it floor material. This will be a transparent material from the universal render pipeline, unlit and transparent, and the alpha value will be 0. And another material for our line material, this will be the line material. And this again will be unlit, and as in the previous tutorial, we're just going to make it blue. Yeah. Okay, let's create a new game object, call it navigation line. And this will get a line renderer component. We'll just set the positions to 0 so that we won't have this initial line here, and the materials will be our line material. Okay, that's looking good. And another empty game object will be called indoor navigation. That's where the magic happens. And we need a prefab for our tracked image. We'll just create it in the hierarchy. We'll just create an empty, call it tracked image. And it's just a prefab that will spawn, so there is no component needed. I guess we should do some kind of offset. No, it's fine. Let's add a plane. This will be our floor, and add the floor material and a cube, small one. This will be the center. This will be just occluding our image, 10 centimeters. Then we need the target cube. This will be our target, and know where it is placed. This will be, by the way, in meters from the scanned image, so we'll need it in 0.67 meters to the right. And instead we'll need -4 with this target cube after we scaled it correctly. We'll have an offset to our center. This will be for the calculation of our NavMesh, and we need a few walls, so adding another one, another cube, call it wall 0, 0, and duplicate it, wall 0, 1. And this wall will be -1.87 over here, and the scale will be 5.8 and 3 in height. You can see we're starting over here, and we're going to walk around this wall to this cube, and the second wall will be 5 in x, -1.3 here, and 3 in the y, and 4.6. Okay, so we have our way from down here over there, and to make it invisible, we'll just add the floor material here, unlit floor, but we'll leave the collider, and we need the mesh renderer for the NavMesh to work after that. And now it's time for the magic. We're going to select the floor, adding the NavMesh surface here. We're seeing that our humanoid character is maybe a little bit too much, but we'll try it anyways. Okay, it's very small here, so this should be the way that is calculated, which basically works, but we will just configure that so that the radius of the humanoid character is not that big. Let's go to Window, AI, Navigation, and in the navigation window, let's change the radius to 0.1. We want a very small humanoid character here, and rebake the mesh, and we see, okay, when we are going to wander over here, this will already work. It will have enough space for us to walk through. Make sure the virtual walls are aligning with your physical space, so there will be some kind of measurement to do. And again, the walls are in meters and perfectly matching the physical environment we're in. But that's it. This is the direct image, and this will be our prefab that we will spawn after we have scanned our image. Make a prefab by dragging it into the project window and delete it over here. And we're now going to create a script. I'll just call that navigation target. This will be just an empty script. You can also use tags over here, but it's very simple to just do it like this. Wait for the editor to finish everything. And we'll just empty that. Wait a second, that's not what I wanted. I wanted to do this one. Make it a little bit bigger for you, although it's empty. Just so you can see that there is nothing weird going on except my zooming skills. Saving empty class navigation target. Now open the prefab, go to target, and add the script navigation target here. So this will be our navigation target. Autosave is on, and we're going back, and we're creating a new script called one script new indoor nav. Open it, delete the default methods, and let's start with two things. First of all, we need a player and the AR tracked image manager. The player will be our camera, and the tracked image manager will give us the possibility to react to events that are happening. And we are specifically interested in the trackables changed event. So every time it's enabled, we're going to add a listener for the trackables changed. And on disable, we're removing the listener here. And the onChanged event is pretty simple. In the onChanged event, we're going to check if there is a new image added, an image updated, or an image removed from our image tracking. And to do that, we're going to initialize our prefab that we created earlier here when a new image is added. So we're going to need a game object for that. I'll just call it navigation base. And this navigation base will be initialized when there is an image that we're tracking, and we of course need the prefab here. And after this is initialized, it's possible for us to check for the navigation mesh that's on this game object and to check for navigation targets. And we're going to create these here. So we're creating a list of navigation targets. We're going to get our NavMesh surface, and we're needing something to calculate the path. So first of all, let's start with the path. We have to initialize it on start. We're going to tell our smartphone to not go to timeout or to sleep mode. And as soon as we found an image, we're going to instantiate our tracked image prefab, and we're going to check for possible navigation targets. This code will very likely look different in your implementation, but it's for the sake of this simple tutorial, it's enough. So we're going to just check there's a navigation target in our prefab that we already instantiated, and if there is a NavMesh surface too. And if that's the case, we're going to set the position and the rotation of our navigation base, this one here that was instantiated, with our tracked image. So I'm just using the Unity method here for set position and rotation, and the updated image pose position, this one here, and the updated image pose rotation, while Y, because we're only interested in the Y rotation, the X and Z rotation I just want to keep 0, so the device already knows where the floor is and how everything is in the world. I'm only interested in the Y rotation here. After that's done, that's all that should happen when the navigation, the image tracking is running. And of course we need an update method to check our path and everything that's happening. So we're going to check, did we already instantiate something? This means, was the image scanned? Do we have our navigation targets? And do we have a NavMesh surface which we can calculate on? So we're going to rebuild the NavMesh every time, every frame. It's not ultimately necessary, but you can do it. And you can also comment it out. That's not necessary by any means. And the navmesh.calculate path will start from our camera position to our navigation target. We only have one, so that's sufficient here. We're going to check all areas, and we're going to write it into the navmesh path variable, which will then be checked if the path is complete. And we'll have our line renderer. I didn't add it yet, but I will do it now. We need the line renderer here, of course, as well. To show where the path is. So if the path is complete, get everything from the NavMesh to the line renderer, set the positions, and if the path is not complete, immediately turn off the line renderer. This code too will look different on your side depending on your implementation. That's the whole code, and let's go back to Unity and to indoor navigation, adding the new indoor nav script here, and let's set these references. The player will be our main camera, the AR tracked image manager is on the XI origin, the tracked image prefab is in the prefabs folder, and the line renderer is the navigation line. And because we have installed XR simulation, we can already press and play and check if it's working. So we see that there is a cube, and when switching to the scene, we see that the image was tracked, our prefab was instantiated, the NavMesh is not visible in play mode, and there is a path calculated to our target cube. Okay, the path is way too thick, so we'll just switch it to 0.1, save it, click on play again. We now turn around, we see, okay, the navigation is here. If we switch to the scene, there is navigation on the mesh, and as soon as we're moving around, the navigation line will follow the player and adapt to our movement. And because we're using image tracking here, everything is anchored in the room by the image, and the navigation line is visible. Everything that's now left to do for you is to use the prefab, build your room, your floor, your building, whatever. Have a few navigation targets here, build a small logic for selecting them, or maybe a UI, just left it out in this case to keep it simple. And you have a working indoor navigation with minimal effort in a very short amount of time. Now that the implementation is finished, we just have to go to File, Build Profiles, Android, attach your Android device, click on refresh. It's not popping up here because I don't have my smartphone attached. You can just select it here and go on Build and Run. Select the folder where the APK should be saved. Click on Save. Wait for it to be deployed to your smartphone, start it, and everything should work out. There is a possibility that you have to confirm the usage of the camera, and if the camera stays black, try to uninstall the whole APK and install it again. Sometimes Unity gets a little hookup. So that's it. As with all the other indoor navigation stuff, this will be open sourced on my GitHub. Check out the description box. Thank you for watching. If you have any suggestions or improvements for this, write it down in the comments. Also consider becoming a channel member. Although this is open source and for everyone to use, there will be videos where the source code itself is only accessible if you're a tier 3 member. I'm currently working on a few things, but if you have an idea where you think this would be really great to have a short tutorial, especially in Unity or WebXR stuff, write it down in the comments and I'll talk to you soon. Bye bye.